Hey everyone. So today we're basically going to be talking about the different operators that you have in Python, specifically to do math and also other things. And also we're going to learn today that when you have different types of arguments, the operators behave in different ways. So the first mathematical operator we're going to be talking about is addition. So addition works just as you'd expect, right? If I print 5 plus 5, then I get 10. And if I print 5 plus 5.0, or 5 plus 5.0. The key here is note that 5 is an integer and 5.0 is a float. And it turns out that if you add an integer to a float, it results in a float, 10.0. Now a key thing in computer science is when you do some sort of expression or call a function, you want to know the type that the function returns. And so in this case, if we do anything with a float in Python, then the resulting answer is going to be a float. Now, let's say I have the variable x equals 5. It turns out that I can actually add, if I wanted to add 1 to that variable, I can do x equals x plus 1, right? If I print out x, then it's great, it's 6. However, there's a shorthanded way to add to a variable. You do x plus equals 1. Now this is the same thing as saying x is equal to x plus 1. So I get 6, just as expected. Similarly, you can do x times equals something like 2, which would be the same thing as saying x equals x times 2. So I get 10. So there's a whole bunch of types of shorthands that you can use, and it's just good to know that they exist. Now, the next operator we're going to talk about is division. Now, just like addition cared about if you're using integers or floats, division is even more so. Now, let's say I do integer 5 divided by integer 2. Now, you're probably thinking like, oh, 5 divided by 2, the answer is probably 2.5. Nope, it turns out that 5 divided by 2, in terms of Python, is 2. And this is because it's not doing real division, it's actually doing integer division. Now, what that means is that, essentially, you can think of integer division as let's just do regular division and then throw away the decimal, or get rid of the remainder. So like 5 divided by 2 is what you thought, 2.5, but then integer division, so we throw away the 0.5 and just remain with 2. So for instance, 12 divided by 5, or 12 divided by 7, now if I did the math, it would be 1 remainder 5, but we get rid of the remainder, so we end up getting 1. Moreover, let's say that I do a smaller number like 5 divided by a bigger number like 12. Now, this would be 0 remainder 5, and so we'd end up just getting the 0. So when you do a smaller number by a larger number, you just get 0. Also, it turns out that in these situations, we've been doing specifically integers divided by integers. However, let's say I do 5.0 divided by 2. One of these, the 5, is a float. So now it turns out this is equal to 2.5. And so if you want to make precise calculations, then you want to use floats. And it turns out only one of them has to be a float. So if I did 5 divided by 2.0, I get the same result of 2.5. So one thing that people often do is, let's say you have x is equal to 100 and y is equal to 13. And you want to print x divided by y, but you want to do it with float division, then what you normally do is you'll actually take the float of x, convert x into a float, and then divide it by y. So now we get the precise answer. Now, modulos is an operator that you haven't learned yet, or probably haven't seen before, but it's something that comes up a lot in computer science. Now, the way that you do modulos is you use the percent sign. And more formally, we call it mod from now on. So what mod does is it says, if I'm doing 10 mod 3, how many 3's can I take away from 10? And then what is the remainder? So 10 divided by 3 is 3 remainder 1. And so in mod, we just return the remainder, which in this case would be 1. Also, let's say that I did 12 mod 5. So again, I can take away 2 5's from 12, and I'm left with 2. So if you notice what's happening, we're always getting the remainder. And so whenever I mod a number by another number, let's say I do x mod y, then the result will always be less than y and greater than 0. So let's see what happens when I mod a number by a number that divides it. So like 12 mod 4. So 12 is divisible by 4. So when I get the remainder, it's going to be 0. So when you mod anything by 1, since everything is divisible by 1, you always get 0, or always get 0. So you'll probably learn modulus more and more as we go on, and when you use it more, for instance, in the homework. Now finally, the last thing which you need to know how to do is how to actually use power. So let's say I want to print out 5 squared. So you might think that I do 5 caret 2. However, that's going to do something completely different, which you'll be very confused about. What you actually want to do is 5 asterisk asterisk 2. And this will give me 25. Similarly, let's say I want to get the square root of 5. That's the same thing as saying 5 to the 1/2. And I'll get. So I made a mistake, which you'll probably make often when you're working until you get used to it. But I just did 1 divided by 2, and I assumed that that was equal to 1/2. But remember, 1 is an integer, and 2 is an integer. So 1 divided by 2 is actually integer division, which is 0. So I'm going to do 1.0 divided by 2, and I get 5, the square root of 5. Also notice that we use parentheses to siphon off the math we want to happen first, and Python follows order of operations. So if I did 10 times 5 plus 2, let's say I did 1 in the front, then it'll do 10 plus times 5, 50, and then 1 plus 50 plus 2, which is 53. But you should always use parentheses in your Python expressions, just to be more clear and precise. So finally, we're going to talk about the math module. So in Python, using modules is very easy. So it turns out that somewhere in our computer, when we downloaded Python, there's a file out there called math.py, which has all of these different functions which are going to be really useful for us. So if I want to use those, then what I have to do at the top is write import math. And then anywhere underneath the import statement, I can use the math module. So some of the things it gives you is things like square roots and math.sine and math.cosine. So let's say I want to print out the square root of 25. I do math.sqrt of 25, and I get 5.0. Now you're probably wondering, how do I know that it's sqrt? So what you want to do is go to Google, type in Python math module, and you want to go to, you'll be looking at this website a lot, it's the Python documentation. And here it says the math module, and it shows you can do things like take the ceiling, take the absolute value, take the factorial, take the floor. So there's all these different functions that you can use that are given to you by the math module. So that basically wraps up all the different types of mathematical expressions and operations that you'll find useful in the coming homework and also later on. And of course there's a bunch more that I haven't gone over, but you'll run into them later on in the course. So next time we're going to basically be talking about logical expressions and Boolean logic.